Hi everyone. In this lecture I'm going to go over the first part of chapter 16, which is about implementation of linked lists and the details of how linked lists work in Java. In the previous chapter we have seen the syntaxes of using linked lists and the way that we can define iterators uh, which encapsulate the positions, different positions in a linked list. But in this chapter, we're going to go through the details of implementation of linked lists to get a better understanding of how linked lists work in Java. So as I said, the goal in this part of this chapter is to understand the implementation of linked lists and array lists. In fact, I left the array list part as an optional part of this module, this week's module, so that if you want, you can study the slides of array lists that are posted on Canvas. So the first step toward understanding the implementation of linked lists in Java is to start with a very simple linked list. A simplified linked list that we're going to talk about in this lecture is a simplified singular linked list. In fact, as you remember, linked list in Java is a double linked list because you can both call the previous and next methods for the iterator, but here we assume that we have a singular linked list for the sake of simplicity. And then we know that a linked list stores elements in a sequence of nodes. And a node, an object of a node class, is where we store the element and a reference to the next node. So the first thing that we need to implement for having a functionally for having a functional single linked list is to create a class for node. The class node is an inner class, which means it's not visible outside of the class linked list, and all of its instance fields are public. It has two instance fields, object data and node next, which refers to the next node, and object data contains the data that can be stored in the linked list. And as you see, we define both instance fields public because everywhere in the class linked list we should be able to have access to both data and next node. After defining the class node, the inner class node in a linked list, let's see three main members of class linked list. The first one is an instance field, is a private instance field which is called first, and it has a type of node. The reference first refers to the first node of the linked list, and the default constructor of the linked list class is defined as the first equals null, which basically initializes the private node first to null. So if a linked list is created by its a default constructor, then its first reference refers to null, which means we have an empty linked list. And then there's a method, is a very important method, which returns the first the data in the first node of a linked list. This method is defined in the following way. It's a public method which returns an object. The method name is getFirst, and it first checks whether the linked list is empty or not. If first is equal to null, it means that the linked list is empty, so it throws a new no such element exception object, so it throws an object of class no such element exception. uh, and otherwise, if there exists such if there exists at least one element in the linked list, then it returns first the data. As I said before, first refers to the first element of the first node of the linked list, so it returns the data stored in the first node of the linked list. So let's talk about how to add and remove the first element of a linked list. Obviously, when you're adding or removing the first element, the reference to the first node must be updated. So let's first talk about the add first method, which returns nothing, so it returns void, and it's a public method, and it gets an object element. The element in the public in the explicit input parameter of this method is the object that we are going to store it in the new first node of the linked list. So what we do first is to create an object of node. New node is equal to new node. Basically, it instantiates a new object of class node. So the new node is the node that is going to become the first node of the linked list. So what we do is we first set its data instance field equal to the element, which is the explicit parameter of the method, and we set its next reference to first, which is the current first node of the linked list, and finally we change the first reference that linked list stores, because the first node has changed, so the new first becomes the new node. So this is how we add a node to the beginning of a linked list, and that node will contain the element which is the explicit parameter of the add first method. So here you can see the schematic view of how to add a node to the beginning of a linked list. Initially, the linked list which stores the first reference, and the first reference refers to the first node of the linked list, is shown here, and then a new node that we are going to add with the data equal to Amy exists here. After inserting this node to the linked list, we have the following figure. In fact, first now should refer to the new node containing Amy, and the next field of Amy's node should refer to the previously first node in the linked list, which contained Diana. So this next refers to Diana node, and Diana's node refer to the same node that has previously referred to before inserting a new node. So now let's see how can we implement a remove first method for a linked list. What we should do when we are removing the first element of a linked list is to do the following. First, the data of the first node that is going to be removed should be saved, because later we're going to return it as the output value of the method. And the successor of the first node that is going to be removed should be stored and becomes the first node of the shorter list after removing the first node. And finally, the old node that we remove it will eventually be recycled by the garbage collector of Java. So let's see how we can implement the remove first method. Remove first has no explicit parameter, and it returns an object which is the data stored in the first element that was removed, and it is a public method. The first thing that we need to check is to see whether this linked list is empty or not. If it is empty, which means if first is equal to null, you need to throw a new no such element exception. So there's no element, and therefore we cannot remove anything. But if there is some element, at least one element in the linked list, we do the following. First of all, we need to create a reference to the data of the first node that we are going to remove. So first.data should be the value of a new reference object element. So element refers to the data of the first node that is going to be removed. And first, which is the reference that linked list stores for the beginning of the linked list, should be updated to first.next, which is the reference that the current first node keeps. And finally, you have to return the element, which is the element that is stored in the data of the first node that has just been removed from the linked list. So this is a schematic view of how removing a node, the first node of a linked list, looks like. First of all, you have a linked list containing a number of nodes. The first node has the data field equal to Amy. The second node has a data equal to Diana, and this chain will continue. After we remove, we need to update the first reference of the linked list and set it equal to a reference to Diana's node. The Amy's node would have no, would not be reachable by any other reference. In fact, there is no reference to the Amy's node anymore. So Amy's node is considered to be garbage by the garbage collector of the Java, and Java will eventually remove Amy because it is not reachable by any other object in the program. So the Java garbage collector will eventually remove the node Amy. So what you need to do for removing node Amy is to simply change this reference, and instead of having first refer to Amy's node, make it refer to the next node, which is Diana's node. Okay, so so far we have talked about the class linked list and how it keeps track of the first node, and how a node is defined as an inner class inside the class linked list. Now we're going to talk about the Iterator class. So we want to implement a simplified list iterator interface which has the following methods. First method is next. The second method is has next. Then we have remove, add, and set. As you see, we don't have previous and has previous because we only talk about a single linked list. So we're gonna make it simple, and if you understand the way that we implement a single linked list, it is not that hard to extend this implementation to make it a double linked list. So our linked list class declares a private inner class called linked list iterator. So linked list iterator is like the node class, which is an inner class. And the linked list iterator implements our simplified list iterator interface with those methods next, has next, remove, add, and set. As an inner class, linked list iterator has access to both the first instance variable of the linked list class and the private class node that we define inside the linked list class. So a list iterator object must have a reference to the currently visited node, which we call that reference a position. And also, what else do we need for the list iterator? The list iterator must have a reference to the last node before the node that position refers to. We call that reference the previous reference. And also, the list iterator needs a flag. The flag is called isAfterNext, which basically tracks when the next method has been called. We use this to check whether we have called the next method before adding or removing an element. So here is the inner class linked list iterator inside the class linked list, which is marked with blue color. This class, which implements the list iterator, which is an interface containing add, set, remove, next, and has next, the methods that you have seen in the previous slide. Let's see what's inside this class. It has a private node position to keep track of the current position of the iterator. It has a private node previous, which refers to the previous position. It has a private boolean isAfterNext, which is a flag to keep track of when the next method has been called. And it has a constructor for sure. It should have a constructor. So let's see what's inside that constructor. In this constructor, we initialize previous and position to null, and we initialize the isAfterNext flag to false. In order to advance an iterator or call the next method, what should we do? First of all, we need to update the position, which was a reference to the current node. And secondly, we need to remember the old position for the remove method. So here is the implementation of the next method. As you see inside the class linked list iterator, we define a method called next, which returns an object. First of all, it checks whether it has the linked list has the next method, has the next node or not. If the linked list has no more nodes, we need to throw new no such element exception because we have reached to the end of the linked list, so there is no next node. Otherwise, previous should be set to the current position. We should remember the current position for implementation of remove method that we will see later. Then you have to set isAfterNext flag equal to true because we are calling the next method, so this indicates that we have just called the next method. Then if the position is null, which means that the current position has been null, so position has to refer to the first node in the linked list. This is just for the first next method call. If you remember, the constructor of linked list iterator initialized the position to null. So if the position is null, it means that we have just called next method. So position should refer to the first node in the linked list. If the linked list is empty, therefore, then the first is null. So there's no problem if we have an empty linked list. If position is not null, which means that this is not the first time that we are calling next, position has to refer to position dot next. So we have to advance the iterator. And finally, we have to return position dot data, which is the element that is stored inside the node that position refers to after being advanced. Now let's see how has next method works, because inside the next method we call has next method. So let's see how can we implement the has next method. In order to implement the has next method, we need to know when the iterator reaches to the end of a list. There are two cases in which the iterator reaches to the end of a list. The first case is when the list is empty, which means the first is equal to null. The second case, which is a more common case, is when there is no element after the current position, which means that the current position is the current position points to the last node in the chain of nodes. So position.next is null, is the condition for the second case. So here is the has next method. It returns a boolean. It is either true or false. If the position is null, then you need to return first is not equal to null. So if the position is null, you need to check whether the list is empty or not. If the list is empty, you need to return false, and if the list is not empty, you need to return true. Why? Because if the list is empty, obviously there's no has next, so you have to return false. If the list is not empty, you need to return true, because although position refers to null, but the the linked list has the next element, because we haven't called the next method yet. That's why position is null. So position being null is not always a bad sign. Position being equal to null means that we have just initialized position, and after initialization of position we have never called the next method. So it means that if the linked list is not empty, there should be the next method, so you have to return true. What's the else case here? If the position is not equal to null, then you have to compare position.next with null. If the position.next is equal to null, it means that there is no element after current position, so you have to return false. But if position.next is not equal to null, it means that after the current position there are still one or more elements in the linked list, so you need to return true. That's why we define the has next method in the following way. So let's see how removing an element in the linked list works, in the linked list iterator works. If the element that you're going to remove is the first element, then you have to call remove first. It's very simple. You have implemented remove first before, so you simply call that method. Otherwise, you need to update the next reference to the previous node. Do we have a reference to the previous node? Yes. The variable previous was made intentionally for the remove method implementation. So what should we do after that? After removing an element, you need to reset the is after next, and you have to update this flag to disallow another call to remove, so that it is not possible to call two removes after each other, or it's impossible to call one remove after another remove without calling next in between them. So here is the implementation of the remove method. First of all, you need to check whether the is after next flag is true or false. If it is false, you need to throw a new illegal state exception, which basically says it is not possible to call remove without calling next method first. Then if the is after next flag is true, then we have to take care of the rest of the implementation of the remove method. If position is equal to first, which means that we are going to remove the first element, then just call remove first and that's it. Otherwise, we need to update the previous node's next reference, and previous node's next reference should be set equal to the current position's next reference. This way we remove the node that position refers to. Then after that, you need to update the position reference, because position refers to a removed node, so it should refer to the previous node. And you have to set is after next equal to false, which means that you're not allowing a second remove method call without calling the next method. So here is how the removing an element in a linked list looks like. This is before removal and this is after removal. Before removal, position refers to Harry's node and previous refers to Diana's node. After removal, Diana's node refers to Romeo's node, which is the next node after Harry, and this way we are bypassing Harry's node, and no other node refers to Harry, so Harry will be considered as a garbage and will be collected by the garbage collector of Java. And interestingly, both previous and position refers to the same node Diana. That's why we need to call the next method before removing another node. So after calling the next method, the position would refer to Romeo. But right now, the state of the linked list and iterator class is not very stable. We need to call a next method to rectify and correct the position and make the position refer to Romeo before calling the next remove method. In order to add an element to a linked list, we still need to set the is after next flag equal to false to disallow a subsequent call to the remove or set method. In the next slide, we'll talk about how to add an element to the linked list. The first thing that we need to take care of is to see whether position refers to null or not. If the position is equal to null, it means that we haven't called next method yet, so position should refer to the beginning of the list, and when you are adding an element to the list, the beginning of the list, it's better that you call the add first method that we have seen its implementation in the previous slides, and then position should refer to first. If position is not equal to null, then it means that we need to take care of adding the element in a different way than the add first method. So first of all, we need to create a new node that stores the element. The element is the explicit parameter of the add method. So new node.data is equal to element. So the next step is to set the next reference of the new node equal to the position.next, because we are going to add the new node in the same position that position refers to. And obviously position.next should be set equal to the new node, which is the node that we are going to add. And then position should refer to new node 2. Now, what should we do with is after next flag? We need to set the is after next flag equal to false, so that we disallow a subsequent call to remove or add method without calling the next method first. So here is the schematic view of how the linked list and its iterator looks like before and after inserting a node. Let's assume that the node that we are going to add contains data equal to Juliet. So we are going to add it in the location that position refers to. Position refers to Harry's node. So after inserting the Juliet node, position has to refer to Juliet's node. Harry's node has to refer to Juliet's node, and Juliet's node has to refer to Romeo's node, which was referred by Harry before inserting Juliet. So if you go through the code, you see how these references are updated inside the implementation of adding an element to the linked list. Finally, we talk about how to set an element to a different value in the implementation of a linked list. The set method basically changes the data in the previously visited element, and it must follow a call to the next method, like the add and remove methods that we have seen before. Here is a very simple implementation of the set method. If the is after next flag is false, you have to throw a new illegal state exception saying that it's not following a call to next method. If is after next method if is after next flag is true, then it has to set the position.data equal to element, and that's the end of the implementation of this method.